Hmm. Okay, good afternoon all of you. In today's session, refraction through a glass slab, we will be discussing a very specific topic related to refraction, that is refraction through a glass slab. So today the entire meeting will only be on this topic. So there is a ray of light like this. Okay, this is the incident ray. Okay, so there is an incident ray. So that means it is going to be incident on a glass slab. So this is the glass slab, as you all can see. This is the glass slab. So there is a ray of light. It is about to be incident on the glass slab, and I is the angle of incidence, as you can see very clearly. So this ray is incident and angle of incidence is I, and angle of refraction inside the glass slab, angle of refraction is R. Now in the glass slab there is a opposite face also. So this face is the face where the ray is incident, and there is an opposite face. So over there also you will have an angle R. So this angle R will be the angle of incidence for the ray which is going out. So the ray which is going out is this is called the emergent ray. So there will be an incident ray, there will be a ray inside the slab, and there will be an emergent ray. And with respect to the incident ray, the emergent ray will be at a displacement that is called lateral displacement. So lateral displacement is the shift between the incident ray and the emergent ray. That is called lateral displacement. So essentially, refraction in a glass slab, the topic is that when the ray is incident, okay, there is a certain angle of incidence, and because glass is obviously denser than air, so the ray will bend towards the normal, so angle of refraction will be less than angle of incidence. Then at the opposite face, this angle will be alternate to this angle. This is R, this is also going to be R, and then the ray will come out, and the ray which comes out is the emergent ray, and this is the angle of emergence. Now this angle of emergence, I have written it as E. Okay, I have written it as E because that is the convention. But if you see very deeply, you will see that angle of incidence and angle of emergence both are actually the same. So this angle of incidence and angle of emergence, I and E, they both are actually the same. Okay, so that is the reason why the incident ray is parallel to the emergent ray. So this is the incident ray, it will be parallel to the emergent ray, but there will be a shift between them. So the shift between the incident and emergent ray is called the lateral displacement. Now this lateral displacement is something we are very interested in. So we would like to study the lateral displacement. So lateral displacement It depends on number one, thickness of the glass slab. So lateral displacement, it depends on number one, thickness of the glass slab. That is number one. Okay, so how does it depend on thickness of the glass slab? So it depends, lateral displacement depends on the thickness of the glass slab. If the thickness of the glass slab is more, then lateral displacement will be more. Okay, so lateral displacement, it depends on the thickness of the glass slab. If the thickness is more, then lateral displacement is more. That is number one. Number two, lateral displacement depends on angle of incidence. Okay, number two, lateral displacement depends on angle of incidence. If angle of incidence is I, obviously. So if I is more, the lateral displacement will be more. So it depends on angle of incidence. If angle of incidence is more, then the lateral displacement will be more. That is number two. Number three, okay, number three, it depends on refractive index. See, there is refraction happening. So refractive index will be an important measure. So number three, depends on refractive index. Now, how does it depend on refractive index? If the refractive index is more, then lateral displacement will be more. If the refractive index is less, lateral displacement will be less. Now I have written over here refractive index of glass, and then I have written comma. This is a symbol for wavelength, wavelength of light. Now there is one important thing you have to remember, that suppose I am using a particular color, like suppose I am using white light only, then I will have to check lateral displacement for angle of incidence, for refractive index of the glass, etc. But suppose if I keep a particular glass slab, suppose I don't change the material of the glass slab, now it is a glass slab of certain type of glass and I am not changing it, then the refractive index will depend on the light which is entering, so the wavelength of the light. And there is a relation that if the wavelength of the light is more, the refractive index is less. Like there are 7 colors in white, you know, violet, indigo, blue, green, yellow, orange, red. So out of the 7 colors, violet has the lowest wavelength and red has the highest wavelength. So if the wavelength is high, the refractive index will be low, and if the wavelength is low, the refractive index will be high. That means who has got the highest refractive index? Violet. So like I said, point number 3, it depends on refractive index of glass, and if you have a particular type of glass, you don't make any alteration, keep that glass only, then it will depend on the wavelength of light. And wavelength of light means that if it is violet, the wavelength is the lowest, so the refractive index is highest. If it is red light, wavelength is the highest, the refractive index is the lowest. So that is point number 3. So this is our topic for today, glass slab. So I'll just quickly refresh the whole topic once more. So in a glass slab is basically a cuboidal thing and made of glass. So the incident ray is falling. This is angle of incidence, this is angle of refraction, this is alternate to angle of refraction, this is the angle of emergence. The emergent ray and incident ray will always be parallel to each other. These two angles are alternate, RR, both are equal. By the way, I and E will also be equal. And So angle of incidence, angle of emergence will always be equal, and incident ray and emergent ray are parallel. The separation between the incident and emergent ray is called lateral displacement. Now we are extremely keen on studying the lateral displacement. So lateral displacement, number one, it depends on the thickness of the slab. If the thickness of the slab is more, then lateral displacement will be more. That is point number one. Number two, it depends on angle of incidence. That means this angle. If the angle of incidence is more, then lateral displacement will be more. Number three, it depends on the refractive index of glass. If the refractive index of glass is more, then lateral displacement will be more. And by the way, if you keep a particular glass, you don't change the glass, then for a particular glass, the refractive index will be of that particular glass, so that's fine. But you may want to change the color which is falling on the glass slab. So remember that among the 7 colors, red has the highest wavelength and therefore lowest refractive index. Violet has the least wavelength, that means it has the highest refractive index. So refractive index of glass, that would mean that it is actually the refractive index of glass, or you might even say that according to the wavelength which you are using. So if it is violet, the refractive index will be high. If it is red, the refractive index will be low. So this is the topic for today, glass slab, right? So based on this, let me give you the usual homework. Okay, the first homework question is that light is entering a glass slab, and after it enters the glass slab, if it goes perpendicularly straight across, that is A. So is that the correct answer? It bends a little and then comes out parallel to the incident ray, that is B. Is that the correct answer? It just goes straight as if nothing has happened, that is C. Is that the correct answer? And it bends away from its original direction and follows the path D. Is that the correct answer? So you have to say which is the correct option A, B, C, D. That is question number 1. Then the second homework question for today. There is a ray of light. It is incident at 45 degree in air and it is entering a liquid at angle of 30 degree and then it is striking a mirror. So angle of incidence in air is 45 degree, in the liquid angle of refraction is 30 degree, it is striking a mirror. So with this diagram you have to first say what is the refractive index of the liquid and after that you will have to complete the path of the ray. So these are the two things you have to do in question number 2. Okay, question number 3. There is a glass slab and there is a liquid. Light is entering from the liquid to the glass slab and then coming out. So the light is entering like this. Now the question is, you'll have to draw two diagrams. The first diagram, if the glass slab has got more refractive index than the liquid, that you have to draw first diagram. Then you'll have to draw a separate diagram if the glass slab has got less refractive index than the liquid. So you'll have to draw two diagrams. So basically this is a question where you have to draw. So today's homework is entirely based on diagram. The second question you have to draw a diagram in the second part. First question, out of these 4 you have to identify the correct ray. And third one, you have to draw two diagrams. If the glass has more refractive index than liquid, that is number 1. If the glass has less refractive index than the liquid, number 2. So you have to draw two diagrams. So these are the 3 diagrams that you need to draw. Okay, so in today's class I am only giving these 3 homework questions and that completes our session of glass slab. These 3 homework questions you will have to send the solution before 9 p.m. tomorrow. That means 9 p.m. on Friday. I'll end the session. Thank you all of you.